Yeah. All right, so the first few definitions that we are talking about here probably will not fit on your graphic organizer, so you'll need to write those down on a separate sheet of paper. So we're going to be talking about parallel lines. And we decided on our opener, parallel lines are lines in the plane. That's what is true about these lines.
Not intersect.
They do not intersect. All right, so the other vocabulary word that we need that's on our graphic organizer, it says cut by a transversal. So let's talk about what we mean by a transversal. A transversal is in a plane. A line, array, segment that intersects two other lines, arrays, or segments. At least two others. So if you look at that picture in the middle of your graphic organizer, you see two parallel lines and one line that's intersecting both of those. So that's what we're talking about with a transversal. So a line segment array that intersects two other lines, arrays, or segments. The other thing that we'll need for our homework is the idea. So we have parallel lines, we have transversal, parallel planes. So when do we think planes are going to be parallel? Look at how we define parallel lines and how we're going to extend that to planes. Planes that don't intersect. Parallel planes are planes in space. That don't intersect. So in the room, what would be examples of parallel planes? How we would visualize parallel planes? What's that? The desk and the floor. The top of the table and the floor. Parallel planes don't intersect. The ceiling and the floor. The two side walls. All right. And then the last little piece of vocabulary is the idea of skew lines. Anybody have an idea or know what skew lines mean? What if lines are skew? What does it mean? Have you heard of that before? No? Skew lines are lines in space that are not parallel and don't intersect. So notice we said in space rather than in the plane. So what in the room, what would be an example of skew lines? So how about that corner up here and that corner down there, going the opposite direction? Or this line here that connects these tiles and this line here at the edge of the table. They're not parallel, but they don't intersect. the upstairs main hallway and the downstairs C-wing hallway. Not parallel, but don't intersect. People walking in the two hallways are not going the same direction, so they're not parallel, but they're never going to run into each other. They're never going to intersect. So those would be examples of skew lines. And skew lines have to be in space. All right, so questions on our little bit of vocabulary? Yes?
Basically, the only way that can happen is they can't be on the same level as each other.
Yeah, that's kind of the idea. They can't be on the same level. All right, so let's start in on our graphic organizer. Let me draw a picture here that's similar. And a lot of this that I write down is already written on your graphic organizer, so you won't have to. And I'm going to make these a little further apart. So the picture on your graphic organizer looks something like that. All right, and this is line M, and this is line N, and this is line L. And for our graphic organizer, line M is parallel, this is how we show parallel, to N. And we'll talk more about this later. These arrows, oh, you can grab that. The little arrows on the line show that they're parallel. And we'll talk more about that later. So lines that have the same number of arrows are parallel. So these are parallel lines. Line L is the transversal. You should label that part of your... So make sure you understand that L and M or M and N are parallel. Line L is the transversal. And we have on our graphic organizers, we have 1, 2, 3, 4, 5, 6, 7, and 8. We call the space, the part between the parallel lines, the interior. So between the parallel lines is the interior. And then outside the parallel lines is the exterior. So you should make sure you label those parts on your graphic organizer. Between the parallel lines is the interior, outside the parallel lines is the exterior. Line L is your transversal. All right, questions on that part? Okay, so let's start filling in our boxes. The middle box on the top, corresponding angles. So corresponding angles, what that means, the way that I visualize corresponding angles, they're in the same place. Yes.
That last one we did was which side was that?
The side that says when parallel lines are cut by a transversal, what angle pair relationships exist. Corresponding angles. Corresponding means in the same place. The same place relative to the parallel lines and the transversal. So on your graphic organizer, the corresponding angles are, and I'm just going to write them in pairs here, so you can write these in your box. Make sure you leave a little space here because we want to figure out how they're related to each other. Angle 1 and angle 5. Both of those are above the transversal and to the left of the parallel lines. So we call those corresponding angles. Angle 2 and angle 6 are corresponding angles. Those are to the right of the parallel lines and above the transversal. So they're both in the same place. Angle 4 and angle 8 are corresponding angles. They're below the transversal and to the left of the parallel lines. And then finally angle 3 and angle 7. So looking at your graphic organizer and looking at angle 1 and 5, how would you say they compare? They're corresponding. Do they, how do their, just by how they look, how do their sizes compare? They look the same, right? It turns out that that is true. So in the very bottom, corresponding angles are congruent. So we can put a congruent sign in between each of those. The corresponding angles, when we have parallel lines cut by a transversal, corresponding angles are congruent. A lot of books, a lot of geometry people take this, use this as our postulate for parallel lines. Our book does something else, uses another one of these, and we'll talk about it when we get there. So, our corresponding angles are congruent. Let's look at the, to the left, alternate interior angles. Alternate interior angles. Alternate means opposite sides of the transversal. And interior means between the parallel lines. And these two lines, again, next to each other mean parallel. So the alternate interior angles are the angles that are on opposite sides of the transversal and inside the parallel lines. So angle 2 and angle 8 and angle 3 and angle 5. And judging by the way they look, angle 2 and angle 8 and angle 3 and angle 5, how they look like they compare? Congruent. They turn out to be congruent. So we have a bunch of angles that we know now are congruent when we have two parallel lines cut by a transversal. Questions there? Really the idea today is to fill out our graphic organizer and start to be able to recognize how we talk about these angles with parallel lines. Alright, so let's go over to the right, alternate exterior angles. Alternate means opposite sides of the transversal. And exterior means outside the parallel lines. On the right. So the angles that are on the opposite sides of the transversal and outside the parallel lines are angle 1 and angle 7 and angle 4 and angle 6. And judging by how they look on your graphic organizer, what would we say about these? They're most likely going to be congruent. So alternate exterior angles are congruent. So we're getting a whole bunch of congruent angles. All right, questions then. Now let's go back over to the left. Same side interior. So same side tells us we're on the same side of the transversal. And interior tells us we are on the inside or between the parallel lines. So which angles are on the, which angles would be same side interior? Angle 2 and angle 5, and then same side of the transversal. So go to the opposite side of the transversal. Which ones are on that side of the transversal? Angle 3 and angle 8. And I'm going to say, and the other way you see this written is same side or consecutive. Same side interior. So if we look at those, one looks acute and one looks obtuse, so they can't be congruent. So what possibly could happen with an acute angle and an obtuse angle? They could be, what did you think, Porter? Supplementary. They are supplementary. So what we're going to write for this is the measure of angle 2 plus the measure of angle 5 equals supplementary angles add to 180. And measure of angle 3 plus the measure of angle 8 equals 180 degrees. So same side interior angles are supplementary. That means their measures add to 180. All right, and let's go back over to the right, same side exterior. So same side tells us same side of the transversal. Exterior tells us outside the parallel lines. So which angles on our sheet are on the same side of the transversal and outside the parallel lines? Angle 1 and angle 6. And then on the other side of the parallel line? The transversal, angle 4 and angle 7. And looking at those, one's acute, one's obtuse. So what are you going to guess is true about them? They add up to 180, so they are supplementary. So it's a measure of angle 1 plus a measure of angle 6 equals 180. Measure of angle 4 plus a measure of angle 7 equals 180 degrees. So we have congruent angles, alternate interior, alternate exterior, and corresponding angles are congruent. Same side interior, same side exterior are each of those pairs is supplementary. Our book uses for our postulate, they use same side interior angles as the postulate for all of these, and then they prove everything using that postulate. And let's remember, postulate means, what is a postulate? Something that we, not proven, but we accept as true without proof. So one of these we have to accept as true without proof, and then we can prove the rest. So for our book, they accept this one as true. Usually it's corresponding angles, but any one of them we can accept, and then we can prove the rest. All right, so let's finish up. Let's finish up our graphic organizer at the small boxes at the very bottom. Vertical pair. So here's our picture for our vertical pair. And if you want, you could label these 1, 2, 3, and 4. And what do we know about vertical angles? 1 and 2 and 3 and 4? Complementary, supplementary, intersecting, congruent. There we go. Vertical angles are congruent. So angle 1 congruent to angle 2, angle 3 congruent to angle 4. So there are several vertical angles on our graphic organizer when two parallel lines are cut by a transversal. So we need to know that those are congruent. And then finally a linear pair. So that is on our graphic organizer. There's our picture. We get this. And I'm going to say 1 and 2. And linear pairs, what do you know about angle 1 and angle 2?
Supplementary.
Supplementary, very good. So measure of angle 1 plus a measure of angle 2 equals 180 degrees. So that completes our graphic organizer, the one side. This is the key information for all of chapter 3, really. And we'll be using all of this information for the rest of the year. All right, questions on the graphic organizer?
Do you have an extra worksheet for Maddie?
Extra common core?
No. She doesn't want one of those. I mean, the extra. Mr. Beamer, Noah was an emergency.
All right. I just have one quick example that I want to do. They're pretty easy. It's like, which lines are parallel? Name 2 parallel planes. A lot of the problems are like that. Which angles are corresponding? All right, guys, so let's stay focused for a second. A is parallel to B, and so these two lines are parallel, and I'm going to say that this angle is 130 degrees.
Is this on the real book?
Very good.
No, this won't go on the graphic organizer. So for this, what I want to know is I want to figure out all the angles on this set of with this set of parallel lines that equal 130 degrees. So what's another? So here's one that we know is 130. What can we figure out? What's another angle?
Angle 4.
Angle 4. All right, guys, let's stop talking, please.
Angle 3.
And let's give some reasons. Measure of angle 4 equals 130 because what kinds of angles are these? Opposite sides of the transversal, inside the parallel lines? Interior, alternate interior. There we go.
Number 3, right next to 130 is.
So we can figure out that angle 3 is 50. So let's hold on to that. We'll talk about that in just a second. Let's figure out our other 130 degree angles. Yes? Angle 2 is 130 degrees. And why is that 130? Vertical. And did you have another one, May? Angle 6 is 130 degrees, and that is 130 degrees because vertical to angle 4, yes. And we could also say these two, how are these two related? They're below the parallel line and on the same side of the transversal. One's inside and one's outside, so they are corresponding. Corresponding angles are usually the ones that are hardest to remember. That's the only pair of angles where one is inside and one is outside the parallel lines. So that's another little clue that you could use. But we could also say the corresponding angles or vertical angles, because we decided angle 4 was 130 degrees, so angle 6 has to be 130 degrees. Yes?
The corresponding is when one is on the inside and one's on the outside, but
They're on the same side of the transversal. So these are both above the to the right of the transversal. One's inside, one's outside. So they'd be corresponding. All right, and Iris said that angle 3 was 50 degrees. Can we figure out all the rest of the angles now? This is 50, so angle 1 has to be 50. Angle 7 has to be 50. Angle 5 has to be 50. So all we need is one angle on a set of parallel lines with a transversal, and we can figure out all the rest.
wow, it's like a puzzle.
It's like a puzzle. And you get one piece and all the others fall into place. All right, questions for today? All right. Yes?
Will there ever be ones where they're not like completely parallel, where we can kind of make it?
We will get to those kinds of problems later in the chapter, but that is a good question. And we'll tell how we can figure that out. Okay? So our homework, page 144. All right, as soon as everybody gets that written down, I will put the book page up on the screen. These problems, most of these problems are pretty easy.
I should tell them to just copy it down from the board.
It's nice to have it in two.
You're such a nice person.